In this video, I want to explain what's really cool and useful about the diagram on page 3.10 of the textbook. And I'm just going to recreate that really quickly here. So we've got we've got two y-axes and an x-axis, and that's what makes this diagram a little bit unique. Probably something that that you haven't seen before. We've got wages on the two y-axes, and then on the x-axis we've got labor supplied, or quantity of labor, and that's increasing, going in this direction. And then we've got the quantity of labor in the other region, region B, and that increases, going in that direction. And then we have a couple of demand curves. So we've got the demand curve. Demand equals the marginal productivity of labor in region A times the price of the good being sold in region A. And then over here we have the demand curve for, I'll write that in a different color just to differentiate it, demand curve for region B, and that we have the marginal product of labor in region B times the price of the goods sold in region B, and that also equals the wage, by the way. The demand curve is equal to the wage paid to the units of labor. And then we can find, based on this graph and the intersection of these two demand curves, we can find the equilibrium labor quantity in each region and the equilibrium wage in each region. So here we have the wage in region B, and over here we have the wage in region A. Now this graph, the first time I saw it, I thought it looked a bit strange, and I suspect that the first time you saw it, it looked a bit strange. I want to show you where this comes from, where this idea of having two y-axes comes from, and where the idea of having two demand curves intersect come from. Because we're used to, I think most of us are used to seeing diagrams that look something like this, where we have a demand curve here and a supply curve, and where I'll just put labels on those really quickly. Here we've got demand, here we've got supply, and then where these two curves intersect, we've got the equilibrium quantity and the equilibrium price. But in the graph that we drew above, we have two demand curves that give us the same information, but it's a little bit different, just because there are two demand curves and there are two y-axes instead of just one, as we see in this more traditional graph. I'll get rid of this graph because we've all seen it before and we don't need to keep it here, so I'll just make some space. And I'll show you what's really going on in that graph. So really, that graph is composed of two different graphs. And the first part, unsurprisingly, is, so this is region A, and we could call this the quantity of labor supplied in region A. It's increasing, going in this direction, and we have the wage here. And as usual, this is the demand curve, which equals the marginal productivity of labor in region A times the price of the product sold in region A. And then the other component is just the same curve, or the same graph rather, but for region B. And we have the quantity of labor supplied in region B and the wage in region B. And then we have a demand curve. It's a little bit shallower for region B. I don't need to label it. It has the same label. Well, why not? Go crazy here. So we have demand equals the marginal product of labor in region B times the price of goods sold in region B. And all we've done to take these two separate graphs and turn it into something a little more useful up here, all we've done is flipped this second graph here. All we've done is flipped this graph right here around on its y-axis and combined it with the first graph. That's all that's happened. So we've essentially just flipped it around so that now we have we have all the same features, except it's just flipped around. Hopefully that makes sense. So we've got quantity of labor, now it's increasing in that direction. We've still got wages up here. And then the other curve is still there. I'll keep them separate for now. We've got wages up here and quantity of labor in region A, and it's increasing in that direction. And then we have a demand curve. And all we've done for the unified graph is to merge these two separate graphs together. And I'll show you what makes that possible and especially useful. So one of the key features is that in each of these regions there's some fixed number of workers. So suppose, for purposes of illustration, let's just suppose there are 50 labor units in region B and also 50 in region A. And so there's a combined total of 100 labor units. And so when we draw our graph as 1 with two y-axes, so let's do that now. The sum of labor supply in both of these sectors is going to be 100 because we're combining the two. We're combining, so labor can move now freely between the two sectors, and we can write that that's the labor supply in region B, and this is the labor supply in region A. And we'll put wages up there, and we can find the equilibrium price and quantity. But the other really interesting thing is that what we want to find is equilibrium wages, right? And in order to do so, we need to what we're essentially looking for is a place where wages are equal between the two regions. The wage has to be the same in the two regions. If that's not true, and it is true at this point that I've drawn here, if that's not true, then people will move from one region to the other until wages equalize. And that's going to be true when the two demand curves cross. So that's why we've combined those two graphs into one graph, so that we can find this place where the two demand curves cross and find the equilibrium number of workers in each region. And here we can see what that looks like. Here we can see the equilibrium wage is at that point, and the equilibrium number of workers, the number of workers in region A is all the way up to here, and the number of workers in region B is all the way up to here. And so that might be, it looks like maybe there's 60 here and something like 40 here. That may not be exactly correct, but it's close. Now the other really interesting thing is it's really easy to do a simple analysis. We can see that if, say, something happens in one of the regions, let's say something happens in region B to increase demand for labor, it'll start to get a little bit messy, but we can see immediately that there's an effect in both regions, and we can see exactly what it is. We can see that as a result of this increase in demand for labor in region B, wages, we have a new equilibrium. We have, first of all, more people have moved to region B as a result, right? And wages have increased in both regions as a result of this. So hopefully that makes sense, and hopefully I've made this concept just a little bit clearer by showing you how this larger graph is composed of two smaller diagrams merged into one.